Before you understand RabbitMQ, you must know the concept of message broker. What is message broker? A message broker is a software system that receives messages from one application or a publisher or a producer. RabbitMQ under the hood is a message broker. It receives messages from one application, from producer, and deliver the message to another application, a consumer. It under the hood implements publisher subscriber pattern, and it ensures communication between two application or three or multiple services or multiple application without talking to each other. Think of it as like a post office for messages. Apps drop their message into the broker, and broker makes sure they get delivered to the right destination. These are all the common message brokers: RabbitMQ, Kafka, Redis Stream, Amazon SQS. Let's talk about why do we need message broker. Without a broker, service or microservices or multiple services talk to each other directly with HTTP or WebSockets or gRPC. This creates the problem in distributed or microservices environment. When you communicate between one microservice or one service to another service, there is a HTTP way which is synchronous, which sometimes is a slow process. So RabbitMQ is asynchronous communication. Message broker solves basically most of these pain points. Decoupling. Producer don't need to know who is consuming the message, when they are ready, and how many consumers are there. This means you can add or remove services without changing others. Let's say order services publish an event order created. Inventory, payment, notification services all subscribe to it. So it provides the decoupling. And this is the most important for RabbitMQ asynchronous communication. Let's say you are building the e-commerce microservice based application. You have inventory service microservice, another one is payment microservice, and third one is notification microservice. So how will you communicate? Let's say order is created, we would like to generate the payment, so we need to send the order ID to the payment service. The way you do it with HTTP, that is very slow. When a lot of traffic coming, your app will be slow. So message brokers let you send message asynchronously. The producer just sends a message and continues its work. And consumers picks up the message whenever they are ready. This reduces latency and improves user experience. Another advantage is for Rabbit broker is reliability, message persistence. Let's say your note inventory service is down, and user send or service make the call to payment. So message will be on the queue. When your inventory service will be restarted, it will send the message again. Acknowledgement is a spectacular concept or feature of RabbitMQ. Retries is another. Let's say if consumer fails, then he can send the message again. Dead letter lock queues, stored field messages for later processing. This ensures no data is lost, even during crashes or network issues. Reliability is spectacular concept or feature of RabbitMQ. If someone will ask you why do we need RabbitMQ, if you will explain these two concepts, asynchronous communication and reliability, he will understand you know the concept of RabbitMQ or message broker. Distribute messages, load balancing. Just a broker can distribute messages among multiple consumers, handle millions of messages per second, enable horizontal scaling of microservices. This is crucial for high traffic apps. Yeah, it supports the event driven architecture, loosely coupled and easier to extend. Why do we need to use specifically RabbitMQ? RabbitMQ is most popular open source message broker. There are multiple open source message broker. Kafka is another one. But These are the features of multiple message patterns, simple queue, publish, subscribe, protocol support. RabbitMQ under the hood works with advanced message queuing protocol. This is the industry standard: reliability, message persistence, acknowledgement, durable queues. It can handle 100k plus messages per second. This is the most scalable option. Create management dashboard, monitoring. You can also do monitoring. These are a couple of the features of RabbitMQ. Multiple messaging patterns, simple queue, protocol, reliability, performance, observability. RabbitMQ ordering per queue, like you can understand this one. RabbitMQ is best for microservices communication. This one is used for lot of companies are using from microservice communication when you need task queue or event driven workflow. Kafka is better for event streaming. When you stream the multiple or large quantity of the data, then you need Kafka. Analytics pipeline handling terabytes of data per day. It is just a simple basic example of RabbitMQ. We have an order service. Order service publish an event order created event, right? And payment service will listen to the order created event. It charges the user. And inventory service listen to order created to update the stock. Email service listen to order created, sends the confirmation email. If you have worked in events in Node.js, the same concept is using here. This is the producer. Producer will produce the event, publish the event like order created in the order events queue, order created, and all of them like inventory service, email notification, all of the are consumers. So consumer will get the message from the order events and order created, waiting for the event. This is the code consumer will use channel.consume. He gonna first bind to the order events queue and look for order created topic order.created. This is the topic in order.created is a topic event, topic queue. And you have to call the consumer orders. Consumer order is constantly listening mode. A message broker is like a postal service for your service. It makes your architecture decoupled, reliable, scalable, and asynchronous. I have a question: when to use RabbitMQ Kafka? RabbitMQ delivers the message reliability to whoever needs to do the work. Kafka is used for streaming processing data, like big data pipelines. Then you need Kafka. For Redis is another option for message broker, lightweight. If you have a small type application, you can use the Redis for PubSub notification. These are multiple options in the market: RabbitMQ, Kafka, Redis, PubSub. I told you what is the concept of RabbitMQ. Kafka event streaming platform for storing and replaying the ordered event logs. In memory publish. This is only used for small applications. Under the hood, Kafka is used for streaming large amount of data, but when you work with data with messages like without video streaming, then you need RabbitMQ. We're gonna use Docker to install RabbitMQ. I have provided the starter kit code. You can find this repo and clone it, and you should be in the main branch. There is just a simple consumer producer empty folder. Here's the tsconfig settings, and I have a couple of dependencies for getting started. You need amqp. RabbitMQ works in this library, amqp, and we have installed a couple of TypeScript and typing for amqplib. We're gonna start producer consumer for testing by running this script. I want you to install npm install. You can say that name should be RabbitMQ Node.js tutorial, right? You should run the npm install. I have already installed all of my dependencies. Next, we need a Docker Compose. We're gonna use Docker for installing RabbitMQ. Let's define the version. It's 3.8. Docker compose.yaml. docker compose.yaml. Yeah, 3.8. Let's define the services. We need RabbitMQ, and we need the image. Image name should be RabbitMQ. I think I'm gonna install the latest version. The latest version of RabbitMQ, I have to find it out. RabbitMQ Docker image. I think 4.14, something like that is the latest version. Yeah, 4.1.4, 4.1.4 dash management. We're gonna use this image. Let's set the container name. You can use RabbitMQ, however you wanna use container name. By default, RabbitMQ listen on the port 5672. Let's set the port. I'm gonna set it to 5. By default, RabbitMQ works on 5672. I'm gonna 5672, right? It also have a graphical user interface. We also need to map that port 15672. 15672. Yeah. Now we have to set a couple of environment variable for RabbitMQ. By default, it works with guest username and guest password. For that, I'm gonna use custom username and password. Rabbit default user. It should be, I can say, admin, and Rabbit default password, I can say admin 123. Do not use question mark, use colon here. That looks good. Admin I don't need here. Next we need to set the volumes. I will define my volume, RabbitMQ data. I'm gonna save my RabbitMQ related files, RabbitMQ data in the var_lib / RabbitMQ in the container directory, into the container. Let's define our volume. I'm gonna set the volumes here. Let's define RabbitMQ data. Image RabbitMQ 4.14 management. That looks good. Container name RabbitMQ, port 5672, 15672. RabbitMQ, that was the issue. RabbitMQ default password, RabbitMQ default password, default user, volume RabbitMQ underscore data. I think that looks good. So we have to test that code. Docker compose up. It's gonna pull images for me. RabbitMQ environment. Oh, I don't need to add this array in the environment. Follow that syntax for environment. Volumes must be mapping. Volume must be mapping. RabbitMQ. Why it is giving me the error? var_lib RabbitMQ volume. Oh yeah, here the volume should be here. It's gonna pull the RabbitMQ image for me and start the container. RabbitMQ image has been pulled. It's gonna attach the RabbitMQ container. Now my RabbitMQ is running now. You can double check that from here. RabbitMQ demo. This is my RabbitMQ. You can see that RabbitMQ is working now. Now we're gonna integrate RabbitMQ with Node.js. Before integration, I want you to understand the concept of producer and consumer. In microservices based application, one service often needs to notify another. If they talk directly with HTTP calls, we get tight coupling and potential data loss when the service is down. We need a middleman that safely stores and delivers messages. Here RabbitMQ works. RabbitMQ comes into play. You will have producer. Producer will publish the message. This message will be stored in the queue, and here subscriber or consumer will consume the message. Let's say order is created in e-commerce application. Customer placed the order. We need to send the notification to the user. The order details will be stored into the queue, and this queue will send the message, or notification service will listening or consuming the message. The message will be received and notification will be sent to the user. So RabbitMQ is a message broker. It decouples like producers from consumers and persist messages until they are processed, and helps the scale the system. Under the hood, producers sends the message, queue stores messages, and consumer receives and process messages. You're gonna see this pattern in RabbitMQ a lot of time. Let's simplify our code. We're gonna build a minimalistic consumer and producer. First, we're gonna build producer. Producer will publish the message. We need to import amqp from amqplib, right? Here I'm gonna run the ify like async immediately invoke function, because we need to run asynchronous code. That is why I use that. Const connection. First we need to create the connection with RabbitMQ. Here we have to provide our connection string. If you have installed .env, you can get that env. Right now I am gonna do hard code that. amqp and name username. You can get that username from the Docker Compose. We set the admin, and the password we set the admin 123 at, which is the host, which is localhost, and 5672. That's the connection string. Next we should get the channel. Connection dot create channel. We should create the channel. Don't worry, I'll explain what is channel, what is connection. Queue. Let's say I'm gonna set the task queue. Await channel. I have to create the queue. If it exists, then we should get the queue, which is queue. Assert queue is create if it does not exist. If it exists, then give me the queue or get the queue. Channel dot send to queue. This is gonna publish the message in the queue. Like publisher, you will use the buffer from the string, convert string to buffer. Hello RabbitMQ. So producer is producing the message to the queue, right? To create the channel, you can log the simple message. I can say message sent. At the end, we should close the connection and close the channel. Dot close and where channel connection dot close. On the next hand side, on the consumer will listen the message. This one is producing or sending the message to the queue. Consumer should be listen to this message. So I need this same code. Make sure you call that function. sync if I'm gonna copy the same code and paste it here. We need channel, and let's write the code for consumer. We need connection string. We need to create the channel. We should use the queue. The queue is task. Yeah, we need to create the queue or assert the queue. Wait, channel dot assert queue. If it does not exist, then create it. If it exists, then do nothing. This is one is a message. Here you can say waiting for messages in queue. This consumer will be on the listening mode always. Next, we should use we don't need to close the connection here because consumer will be on the listening mode always. Channel.consume. I want to consume the message from the queue. This one is my message. We are sending in the buffer, so we need to convert into the JSON. Message dot, let's see, I can say received. I can say message dot content dot to string. Next, we should channel dot acknowledge that message has been received. Message has been consumed. Now to test that, we need to. I have created the script to run the consumer. First, we need to run the producer. Message sent, right? Message has been sent from the producer. Now npm run start consumer. You can see received hello RabbitMQ. Now it is on the listening mode. Consumer is on the listening mode. I'm gonna send the different message. Hello different message. Right. So I'm gonna send consumer is on the listening mode. I have to send that message. Message sent, and you should receive the message hello different message. Let's say producer again sent the message. I will receive hello a different message again. This one is the RabbitMQ communication on the assert queue. Basically, if queue does not exist, then create. If it exists, then do nothing. This one is the send to queue. We need a buffer, convert string to buffer. And here we are consuming that. We are getting message or content or to string and acknowledging that to producer that we have received or consumed the message.